for experiment 3, again, make sure that you have zeroed out your scales. These are not highly sophisticated instruments, so they will wander a little bit. Zero them out. Make sure that your hand isn't actually touching the scale to make it offset some. And we should figure some dimension, and let's make this dimension, say, 12 inches from R2 or 12 inches from R1. Let's, for convenience sake over here, do it at 12 inches from R1. So again, we'd make it a little tick mark. You don't have to do it at 12 inches. You can do it at any dimension. And I would suggest for this one that you set the brick, again, the mark that you put right on the center of the brick that you're going to set down here, such that this dimension from the end of the beam to the center of where you set the brick should be 12 inches, as close as you can possibly get it. And then this dimension would be the remainder of that 12 inches subtracted from 42.125 inches, or 1 1/4, whichever it was, I forget. If you forget, you can always go back and look at what you wrote down, and this becomes our A dimension, this becomes our B dimension, and from here to here is our L dimension. Again, you can work in inches, you can work in feet, but you should not mix inches or feet. And again, in real structural applications, we almost always will work in feet. There are exceptions to that, but we'll almost always work in feet as opposed to inches. As long as you don't try and mix dimensions without a conversion, you can do it either way. And in this particular case, we should come around again and look at the weight on the scale here. And here we have for R1, and this is experiment 3. For R1, we have 3.75 pounds. And for I wrote it in the wrong place, so scratch that out. R2, we have 1.25 pounds. And now, you should intuitively be able to see why this reaction is greater than that reaction. Remember Newton's third law. We talk about that a little bit, actually a lot in some of the reading that you should have done the first week. And we talk about it a little bit in the experiment write-up. For Newton's third law, for every action, there's an equal and opposite reaction. So this brick is pushing down here, and most of the load is going here. Some of the load is going here. When we put the brick exactly in the middle, half of the load is going here to reaction 1, and half of the load is going here to reaction 2. And hopefully you can get through this in short enough time to be able to then derive formulas to predict any load at any location, whether it be a uniformly distributed load or a concentrated load anywhere on the beam, and come up with formulas to actually describe that.